Hello and welcome to unit number 4 of the second week of our course. It's about perceptual design again, about perceptual rule sets, now about condense and check. And I would like to start with condense and show examples of how to increase information density in other disciplines. This one is again an electric circuit with a little information density, and here we have a much more condensed example which could be even bigger and more complex in reality. And I would like to come back to music. This one bar we have seen before has a little information density, but when we see the complete concerto, which is about 30 times as much information on these 2 pages, it's the real world of sheet music. And I also would like to come back to this one example we discussed in the simplify part. This was this rather ugly example of a graphical display, which could be made more simple by using these success rules. It looks like this, and we could now increase information density. That makes we make it smaller, and maybe show 4 times 3 little charts on one page, like here. And we could even put more information on this. Now we have around maybe 20 different charts, and we could see the big picture. We get an overview, and we could see the important and less important countries contributing to net sales. And I would like to take an example from an annual report. This time it's an SAP report from 2010, where we have several charts talking about sales and profit. There are 3 here on these 2 pages, and there are 2 pie charts, 2 circles more on these pages. Altogether, we have something like 10 or 11 different pieces of visualizations representing sales and profit. But it's very complex, it's very difficult, it's not easy to really get an overview what is SAP doing in this business. So, well, I can repeat some issues we already had and then come to the condensed part. For instance, here, no rings, no pies, no circles. We talked about this. There are better means of transferring information. It's only a one-dimensional thing. We talked about the direction of time. It is difficult for us to understand it if the time goes in a table in the opposite way than in this chart. And of course, scaling is an issue. We will come back to this in the next unit, which means we have the need for consistent scaling. So here that the 2010 values of total revenue do not look the same as the research and development, which is 1.7 billion versus 12 billion. So what can we do? We can stack the revenues, these 12.5 billion in those days, in a very simple column chart. We can subtract the expenses and then show the effect on profit. Properly scaled, very simple, easily labeled. And then we, of course, increase information density because we have the figures of 5 years. We can increase information density for revenues, the same for expenses. So we see here the influence of the support revenue, which goes up from 3.5 to 6.1 billion, and now we increase the information density here with the expenses, and we see where the expenses have the biggest growth rate, which is sales and marketing, from 1.9 to 2.6 million, and profit is more or less stable. The profit after tax here amounting to 1.8 billion. Okay. Then, well, we have a little room left here on the left-hand side, so we can put the other 2 revenue cuts on this page. This is one revenue by region. Instead of using this pie chart, I put the revenues by region also on this page, plus the revenues by industry. which gives us the full picture, replacing those 11 parts we had before. We have a clear title. We might add the operating margin here. The operating margin is shown in this on the right-hand side here in a line chart, and we add, of course, a title in order to transfer our message. SAP increased revenues by 33%, and you know what is missing? We need a highlighting arrow to show it. It's 33% growth, but at the same time, the operating margin went down from 26 to 28% in the same time span. So when we compare this one slide, this one picture, with these 11 little ones we had before, I can imagine that it's easier to understand the business of SAP than we have seen it before. 3 little examples explaining the need for condensing information. Now, I would like to talk about check. Check, ensure visual integrity. I here would like to talk about proper scaling only. That's the most important part. We need a proper scaling concept. And here again, a typical example of a PowerPoint slide. I don't know why they do this, but when you look here, you see very quickly that it has a truncated axis. It starts not at 0, it starts at 2. And so when we do it properly, we don't see this development, but when we start at 0, it shows a different development, and this would be properly designed, and this is not correct because it does not really visualize it correctly. That's one typical example, truncating axis. The other one is, I come back to this dashboard we had before, it's not using the same scale for different charts. Here, I look only at these 3 charts at the bottom. We have these top 4 markets and top 4 products and top 4 sales channels. We had it before, but it's not properly scaled, because if we scale it properly, we don't need the labels at the axis. We don't need them, but we rather scale it properly, label it properly, and then it's easy to understand. Another example from this annual report we have seen before. Here you see these 3 charts, but we get the wrong impression because they're not scaled properly. The 3 billion of software revenue looks exactly the same as the 12 billion of total revenue. So if we scale it properly, then we get the proper and the correct impression. I think it's a necessity. It must be. But there are some companies and some large organizations already using our IBCS standards, even in their annual report. And one of them is the Swiss Post. The annual report of the Swiss Post for more than, I think now 6 years or so, are using the rules, and they're even using a scaling concept, which is very unique. It might have been the first one in the world, which says all charts are shown to scale the present and true and fair view. 20 millimeters is equivalent to 1 billion Swiss francs, which is very, very normal for architects, for engineers, or for geographic maps, that people say, well, 1 mile equals 2 millimeters, or 1 kilometer is 2 centimeters. This is quite normal, but it's not normal at all in annual reports where the scaling somehow is not standard all over the report. So what does it mean now? When we look at charts, you see here on the left-hand side these 800 million of normalized operating profit were even shown in this way on the right-hand side, because the operating income was much bigger, and so they had to use this visualization to do it properly. This is quite interesting. When you look in the report, every single chart is visualized in the same way if we talk about billions. Of course, the post office sells stamps, and the stamp prices, of course, have a different scale, but they are not looking the same. They have a different visual design. Okay? To wrap it up, we have touched now 4 aspects in the perceptual design. We talked about express and simplify in the last unit, and today about the other 2, which means condense and check. And the last unit, which is now missing, is coming again back to the unify, the semantic part of our concept.